All right, so this video will focus on 10.1, and we're really looking at probability now. So the first thing we're going to do is, because probability deals with parts of total outcomes, we're going to talk about fractions to start with, just as a review. So what I'd like for you to do is look through these various fractions and try to put them in simplest form. Now, of course, we look here, and 12/50ths is exactly the same as 6/25ths. You don't really have to simplify it to explain that. We simply simplify it because it's easier to multiply together or to do other things to that smaller fraction. That's why we simplify things in math. So take a moment and simplify the rest of these. All right, so hopefully you paused the video and you checked it. Here we go. So 1/2, 4/5, 1/5, 3/5, and 4/7. And what we want to do today is figure out in the experiment, how could you determine the total amount of possible results? So let's look at a couple different examples here. So I flip a dime, right? So I either have a heads or a tails. And what we're going to do first is something called experimental probability, meaning you're going to flip it 20 times and see how many heads you get and how many tails you get. Now here's the thing. It should be at roughly half, but you might go on a run where maybe you get 12 heads and only 8 tails. That isn't 50-50. This is experimental. But the more you play, the closer you get to that theoretical or what should happen. So if I play 1,000,000 times, chances are it will get close to like 500,000, 500,000. The next one says you spin a spinner, and there are how many different results? If I look here, for the first one, there was only 2 results, either heads or tails. For this one, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different results, right? So, oh, I'm sorry, look at the wrong spinner. I apologize. This spinner here. There's 1, 2, 3, 4, 5. So there's a total of 5 different results. How many, if I spin it 20 times, what should happen out of 20? Well, if there's 5 of them, that means that roughly, probably 4 out of the 5 or 4 out of 20 times should be here. And I got that because I took 1/5 times 20 and I got the number 4. So I should get around 4. But again, this is experimental. It might not be perfect. The 1/4 or the 4 times is theoretical probability. If I look at this one here, there's 10 different outcomes. So that's what I have here out of 20. What do you think your chance that you spin a 4 is? Well, probably 2 out of 20 since there's 10 outcomes. I'll probably hit, that'd be like 1/10 times, well, I'm sorry. So I have 1/10 times 20, which would equal the number 2, which means you should get any number 2 times, theoretically. Again, for experimental, we don't know though, right? So this one here says, do you have a better chance of spinning an even number or a multiple of 4? So if I look here, an even number or a multiple of 4. So even number, that would be, let's just circle these so I know what I have here. So even number would be this one here, 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 or this one here. 1, 2, 3, 4, wait. 1, 2, oh, that's a 9. I'm sorry, I thought that was a 2. So 1, 2, 3, 4, 5. I have 5 out of 10 ways to get an even. And to get a multiple of 4, I have 1, 2. I have a 2 out of 10. So if I just look at these two odds, I have 5 chances of winning here and only 2 chances of winning here. I like these odds a lot more. Next one says, do you have a better chance of getting an even or an odd? Well, if I go back to this and I clear out my ink that I had before, my evens are 1, 2, 3, 4, and 5. And my odds are 1, 2, 3, 4, and 5. So in both cases, for my odds, I have a 5 out of 10. And for my evens, I also have a 5 out of 10. So this is equally likely. I have the same chance, right? Next one says like rock, paper, scissors. Well, if I look here, I have the same chance of winning. This is an equally likely event. That's why we play rock, paper, scissors, to make up a decision. It's a more fair way to play the game. So I have this spinner here. How many different results are there? Well, there are 8. If I just count the numbers, there's 8 different results. Of the possible results, how many can you spin for an even number? Well, for even, there is 1, 2, 3, 4. So I have a 4 out of 8 even. And I have 1, 2, 3, 4. 4 out of 8 odd. So this is an equally likely game as well. There's a couple words here that I want to make sure that we understand. Number one is experiment. An experiment is when you actually play the game. That's experimental, right? So the result should be in line with the theoretical, what should happen, but it might be a little different. Things happen, right? But the more I play, the closer I'll get to theoretical. The results of the game are called the outcomes. So the experiment is playing the game. What happens is the outcomes. A collection of one or more outcomes is called an event. Okay? And the outcomes of a specific event are called favorable outcomes. So for instance, whenever it says choosing a green marble, that is the event that I want to have happen out of all of these various outcomes, right? So my favorable outcome in this case, because I want to get a green, would be how many times do I get two? Or I'm sorry, how many times do I get a green? If I look here, my total outcomes are 1, 2, 3, 4, 5, 6. That's my possible outcomes. And my favorable outcome, like what I want to have happen here, would be 2 out of 6 for a green. If I change the question and said the choice or choosing a blue, now my favorable outcome would only be a 1, right? So just so we understand the terminology. So I roll a number cube. How many total possible outcomes are there? Well, there's a total of 6, right? Whenever I do a dice or whatever, or a die. What are the favorable outcomes of rolling an even number? Well, I can get a 1, a 2, a 3, a 4. Oops. Oh, well, there it is. 4, 5, or 6. So I have a total of 6 outcomes. My even number would be the 2, 4, or 6. So that would be 3 out of 6. And then what are the favorable outcomes of rolling a number greater than 5? Well, there's only one number greater than 5 there, right? Just the 6. So that's a 1 out of 6. So you randomly choose a letter from a hat that contains letters A through K. What are the possible outcomes? Well, A, B, C, D, E, F, G, H, I, J, K, right? What are the favorable outcomes of choosing a vowel? Well, there's A, E, I. So my fraction that I have here, my chance of pulling out this is my possible outcomes, which would be 2, 4, 6, 8, 10, 11. And there's 3 out of 11. So I have a 3 out of 11 chance of winning this game. What are my chances of losing this game? Unfavorable outcomes, right? Not favorable, unfavorable. So I take 11 minus 3. Still have 11 here as my total outcomes, right? And 11 minus 3 is 8. So I have 8 out of 11 chances of losing this game. When I add these two fractions together, I should get 11 out of 11, or 100% of my options. So hopefully that makes sense to you. So if I look here, how many possible outcomes are there? If I look here, there are 6, right? So I'll just put a 6 here. How many ways could you spin a red? So this is my favorable outcome, spinning red. I have 3 out of 6. How many ways can spinning not purple occur? So not purple would be 5 out of 6, right? What are the favorable outcomes of spinning not purple? Well, let's look here. So if I have here, first of all, I have 6 possibilities. I have 3 out of 6. So I have 5 sections that are not purple. So spinning, here are the various ways. The favorable outcomes are red, 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 green, blue. That would be spinning not purple. These are all not purple, right? So those are different ways. And then I randomly choose a marble. How many outcomes are there? Well, there's 2, 4, 6, 8. How many ways can blue occur? 2 out of 8. And how many ways can choosing not yellow occur? Weird way to talk, right? But there's 1, 2, 3, 4, 5 different ways that it's not yellow. And here are the various options that you could have. So for the favorable outcomes, you have to actually list them out here. And that's really the lesson today. It's kind of an intro into probability.